Hi, I would just like to show you how to prove that the sine of a plus b equals sine a cos b plus cos a sine b. So if we just start off, we draw like a double triangle with two triangular segments where the very top hypotenuse is 1, and then the angle of each segment, kind of like the wedge angle, will be A and B. And then if you draw them initially so that the whole thing is a right-angled triangle, it means that the overall vertical height must just be the value sine A plus B, because we've got the hypotenuse of 1. So that's how we start. Now what we need to do is, we need to then just take this top triangular segment and we actually pull out, in a sense, the middle rib. So that the top, so in a sense at the bottom triangle is still the right angle, and we pull out we just sort of kind of pull out that segment then, so that the top bit triangle is a right angle as well. And then we then define, so we've got a new sort of extended corner that we've pulled out. So we define h1 as the height from the bottom to this new extended corner, and h2 then is the height from that extended corner to the original height of that overall, what was the overall triangle. And that means then that the sine of a plus b is just h1 plus h2, because it's same, because the original height of the whole thing is the same as before, so it's h1 plus h2. So what we do then is, because we've now pulled out the top triangle, this new extended line, because it's been pulled out until the top triangle is a right-angled triangle, we've still got the same unit of the hypotenuse on the top, which was before. And that means then the extended line itself will now be cos b. And then if you look at h1 then, it will be that cos b, which is the extended line, times sine a. So h1 then, it's cos b sine a. So we need to then get h2. So what we do then is, h2, that's the height of this kind of segment we get by pulling that line out. And I've called this sloping line, I've called it diag, because it's like a diagonal line now, but the actual vertical height of that will be h2. Notice that with similar triangles, you can prove that the top angle of that must be a, because obviously we've got like opposite angles in here, which are the same, and those are like 90. So this top angle must be a here, and the alternate angle there, from this diag to the vertical, that must be a as well, and that's a, and that is h2. So then in that case, then the diagonal itself, that will be, it's like 1 times sine beta. So the diagonal is, so the diagonal is sine of b, isn't it? Because of that angle there. And then h2 is actually that diagonal. It's a diagonal times cos a. And because we know that diagonal is sine b, h2 is sine b cos a. So if you look at the original equation then for sine a plus b, it's h1 plus h2. Now we saw earlier that h1 is cos b sine a, and h2, it's now sine b cos a. So we've got sine a plus b, which is h1 plus h2, is cos b sine a plus sine b cos a. Or just to rearrange it the way that we're used to, sine a plus b, it's sine a cos b plus cos a sine b. Okay, hope you enjoyed that video, and thanks for watching, and goodbye.